If you want to find out the inverse of a 4 cross 4 matrix, how many determinants you have to solve? How many determinants of order 4 cross 4 you have to evaluate? 1. Yes or no? What is A inverse? What is A inverse formula? Adjoint A by determinant A. So you need 1 4 cross 4 determinant evaluation. And in adjoint A, elements of adjoint A are created by considering minor of order 3 cross 3 for each element. So how many minors are there of order 3 cross 3 in a 4 cross 4 matrix? How many minors of 3 cross 3 orders are there in a matrix of order 4 cross 4? 16. 16 3 cross 3 minors are there. So you have to evaluate the determinant of 16 3 cross 3 matrix and 1 4 cross 4 matrix. So you see how difficult it is to find the inverse of a 4 cross 4 matrix. That is why matrix inverse method is not usually used to solve system of equation. In Gauss elimination method, basically whenever we are counting the number of operations, addition and subtraction are not considered, only division and multiplications are considered. So in Gauss elimination method, if the number of unknowns are n, then approximately n cube by 3 multiplication and divisions are required to solve a system of equation. So if n is large, n cube by 3, that is going to be a large number. So to avoid all those things, and one other thing is, if the coefficient matrix is same, but the right hand side values b1, b2, b3, they are changing. Suppose you have to solve several system of equation for which the coefficient matrix will be same, but the right hand side values b1, b2, b3, they will be changing. Then these methods, LU decomposition method, LL star decomposition method, are more useful, because if you want to apply Cramer's rule, each time the determinant will be changing, only coefficient determinant will be same, and whenever you will be evaluating the unknown x1 or x2 or x3 or xn, then you have to replace ith row by right hand side vector, and since right hand side vector is changing, so you have to evaluate different determinants for different systems. So that is why if for a several systems coefficient matrix are same, right hand side values are different, then it is preferable to apply Gauss this LU decomposition method or LL star decomposition method. Now let us quickly solve one problem. Last class I discussed the technique, so I'll be considering the same system which you can see on the screen, and let us see how we can solve it using LU decomposition method. So let me write down the system one more time. Students, am I audible?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So the system is 4x1 plus x2 plus x3 equals to 4. Let me write down one more time. 4x1 4x1 plus x2 plus x3 equals to 4. x1 plus 4x2 minus 2x3 equals to 4, and another is 3x1 plus 2x2 minus 4x3 equals to 6. Now what is the sufficient condition for existence of such decomposition? That the matrix has to be positive definite. So how can you coefficient matrix has to be positive definite. Now, how can you judge if coefficient matrix is positive definite or not? What are the criteria for a matrix to be positive definite? All leading minors has to be greater than 0, or all the eigenvalues of the coefficient matrix has to be greater than 0. Leading minors means first, if you, what is the coefficient matrix here? 4, 1, 1, 1, 4, minus 2, 3, 2, minus 4. So all leading minors are, first leading minor is 4, first leading minor is 4, second leading minor will be 4, 1, 1, 4, and third leading minor will be the given matrix, determinant of given matrix. So these are the leading minors. All leading minors has to be greater than 0. That is the way to say a matrix is positive definite, or evaluate all the eigenvalues of the matrix. If they are greater than 0, then also the matrix is positive definite. So sufficient condition is the matrix has to be positive definite. Then you can say with guarantee that such decomposition is possible. And remember that condition is not necessary, that is sufficient. So even though the coefficient matrix may not be positive definite, such decomposition may sometimes be possible. But if it is positive definite, then you can say with guarantee that it is always can be written as L into U. So here let's see how can we solve this system using LU decomposition method. So here A, it is what? Of the form A times AX equals to B. Okay, what is this is A? What is X? X is the column vector of unknowns, x1, x2, x3. What is B? B is the right hand side known vectors, 4, 4, 6. So let us suppose A equals to, so A is 4, 1, 1, 1, 4, minus 2, 3, 2, minus 4. That is equals to product of lower triangular matrix into upper triangular matrix. So product of lower triangular matrix means what? We are considering, you have to consider diagonals of either L or E matrix to be 1. Here I am considering diagonal elements of L matrix to be 1. So it is 1. Here I am considering diagonal matrix of U matrix to be 1. Okay. You consider anything. You can either consider diagonal of L to be 1 or diagonal of U to be 1. Here I am considering diagonal of U to be 1. So it is L 1 1, then 0 0, L 2 1, L 2 2, 0, L 3 1, L 3 2, L 3 3. So this is L matrix into U. 1 1 1, 0 0 0, U 2 1, sorry, U 1 2, U 1 2. You can give any name. Okay, I am using index according to their position. There is no harm if you use any other symbols. 1, U 1 2, U 1 3, U 2 3. So now what you have to do? You have to find out the matrices L and U. So do the multiplication and tell me what is L, what is U. So you help me with the calculation. So let me do the multiplication. So it will be what? L11, L11, U12, L11, U13, then it will be L21, then it will be L21, L12, L21, L12 plus L22, then it will be L21, U13, L21, U13 plus L22, U23. L22 U23, then it will be L31 U12, L31 U12 plus L32, and the last element will be L31 U13, L31 U13 plus L32 U23, L32 U23 plus L33. So this is the matrix after multiplication. So what will be the procedure? How to find out the matrix L and U? So first you will be solving. You can easily see. Your idea will be to first solve first column of L. Solve for first column of L. Then once first column of L is obtained, you will be looking for first row of U. Then you will be solving second column of L, second column of L. Then you will be solving second row of U. Then you will be solving third column of L. So this is the idea. If diagonal elements of L matrix have to be 1, and then in that case you will be solving first row of U, then first column of L, then second row of U, then second column of L, then third row of U. In that way, in that order you will be solving. If diagonals of L matrix is 1, then okay. So now you use this order and tell me what is L and what is U. You have to solve it. And remember, for any 3 cross 3 matrix, if you consider this L and this U, then there will be a formula. There will be a formula. So it is easy to implement in code. It is not like it will be arbitrary. If you left hand side consider Aij, each element A11, A12, A13, A21, A22, A23, and A31, A32, A33. If you consider that general matrix, and if you solve for these L matrix and U matrix, you will get a formula of Lij and Uij in terms of Aij. Okay, so that is why it is not arbitrary. It will be unique. There will be a unique formula in terms of Aij. So if you keep on changing the value of Aij, from that formula you will be getting different L and different U. So what is L11, L21 and L31? Help me to find out the matrix. We have already solved शायद हम लोगों ने लास्ट क्लास में सॉल्व किए थे क्या इसको? नहीं, पूरा कंप्लीट नहीं किए थे. ओके, हम लोगों ने डायगोनल ऑफ एल मैट्रिक्स को मान लिए थे उस टाइम. चलिए बताइए व्हाट विल बी L11. What is L11? What is
1.
L12? What is L13? Oh, sorry. L21, L231. L21, L31. What are they? 4, 1,
3.
and 3. What then? What will be solved? First row of U. First row of U में क्या आते हैं? U12. So how to get U12? To get U12, you have to compare these two elements. L11 into U12 equals to 1. L11 into U12 equals to 1. So that will be giving you U12 equals to 1 by L11. So that is 1 by 4. So it will be U12 will be 1 by L11. So you see that is in terms of certain formula. लेफ्ट हैंड साइड मैट्रिक्स को अगर चेंज करेंगे तो U12 की वैल्यू भी चेंज हो जाएंगे अकॉर्डिंगली. So it is written in terms of formula. What is the next element? U13. So what will be U13? Can you tell me?
1 by 4, sir.
1 by U13
4,
will
sir.
be 1 by 4. Okay. Next will be second column of L. Second column of L में कौन से एलिमेंट पहले आते हैं? L22. So what is L22?
4, sir.
L22 एक मिनट देख लेते हैं. L22 will be 4 minus L21 into L12. L21 into L12. Sorry, U12. ये तो U है ना? This is U. This is U. This is U. So L21 into U12. So it will be 4 minus L21 into U12. So how much? 4 minus 1 by L21 is what? 1 and U12 is 1 by 4. So 4 minus 1 by 4. How much? 15 by 4. That is L22. What is L32? What is L32? L32 will be 2 minus L31 U12. हाँ या ना? L32 को फाइंड करने के लिए हमको कौन से टर्म को सॉल्व करने होंगे? दिस सर्किल टर्म विथ दिस टू. So what is L32? Tell me.
Four by 3.
फिर भी मिस्टेक कर रहे हो. L32 is 2 minus L31 into U12. So what is this? Let me see.
Sir,
2
5 by 8.
minus what is L31? L31 is 3. What is U12? U12 is 1 by 4. 1 by 4. So 2 minus 3 by 4. How much you are getting? 5 by 4. 4 into 2 8. 8 minus 3 is 5. 5 by 4. Okay. Then so second row of L is second column of L is done. So it will be second row of U. Second row of U में कौन है? U23. So U23 को कहां से सॉल्व करेंगे? To solve U23, you have to consider this element with this minus 2. So what will be U23? U23 will be 1 by L22 minus 2 minus L21 U13. So how much you are getting? Simplify and tell me. This method usually by hand, if you try to solve it, it will seem lengthy, but in code it will be very simple to implement, because for a certain order of matrix, this L and U will be having formula. So what is U23? 1 by L22. L22 is 15. So 4 by 15 it will be 4 by 15 into minus 2 minus L21. L21 is how much? 1 into U13. U13 is how much? 1 by 4. So 2 minus 1 by 4. Simplify it and tell me what you are getting. So it will be minus 3 by 5. So second row of U is done. Next is third column of L. Third column of L में कौन है? बस L33. So to get L33, you have to compare this element with this minus 4. So L33 will be minus 4 minus U31 U13. So L31 U13 minus L32 U23. So you substitute the values and simplify. So it will be minus 4 minus L31. L31 is 3, U13 L31 is 3, U13 equals to 1 by 4. So 3 by 4 minus L32. L32 is 5 by 4 into U23 minus plus. So it will be plus into 3 by 5. So 5 is getting cancelled. This 3 by 4 will be cancelled with minus 3 by 4. So it is minus 4. So now you have obtained U matrix and L matrix. So hence, what is L here? L will be L11, L21, L31. So 413, 413. Next L22. So 15 by 4. Then L32 is 5 by 4. Then 0, 0, minus 4. This is L matrix. What is U matrix? U matrix is equals to 1, 0, 0, 1, 0, 1, and the values are U12. What is U12? 1 by 4. U13, 1 by 4. U23 is minus 3 by 5. So that is the matrix U. Okay, that is the matrix U. Now what is the idea? Now from the given system we will get two subsystem. One will be upper triangular system, another will be lower triangular system, and we can solve upper triangular system by forward substitution, backward substitution. We can solve lower triangular system by backward substitution. Sorry, let me write down, then I'll be telling how we can solve. So now the matrix A, now the system Ax equals to B. So this was given system. From here we have to find two subsystem. One will be upper triangular system, another will be lower triangular system. So what is A now? A is now L into U. So L into U into Ax equals to B. Now what you do? You consider this part Ux. Since X is unknown, U is known matrix. So U into X will be unknown. So you consider U into X equals to some other unknown Y. So let U into X equals to Y. What is Y? Y is, let's say, Y1, Y2, Y3. Then what will happen to the given system? It will become Ly equals to B. So now from the given system 1, we have two subsystems, 2 and 3. So if you solve 2 and 3, you will get one by one. In sequence, you will have to solve first subsystem 3, then you solve subsystem 2, and that will give you the solution of the given system X equals to B. So Ly equals to b. Here L is known to you, b is known to you, y is unknowns, y1, y2, y3. So this is Loa triangular system of equation. This can be solved using forward substitution. So what is Ly equals to b? That will be giving you. Can you tell me the system of equation you are getting from Ly equals to b? 4 y1 equals to, what is b? B is 4, 4, 6. So 4y1 is 4, y1 plus 15 by 4 y2 equals to 4, 3y1 plus 5 by 4 y2 minus 4 y3, that is equals to 6. So that system you have obtained from this Ly equals to b. So solve it. Use forward substitution and tell me. Use forward substitution and tell me what is y1, y2, y3. Y will be there. What is y1? What is y1? 1. Then what is y2? Y2 is 4 minus 1, so 3. 3 into 4 by 15. So 12 by 15. 12 by 15 will be 4 by 5. So y2 equals to 4 by 5. What is y3? What is y3? Y3 will be minus 1 by 4, 6 minus 3 minus 5 by 4 into 4 by 5. So what is y3? What is y3? What is y3, students? Six minus 4, so 2. So 2 by minus 4. So this minus half. So that is y3. So you are getting y vector as 1, 4 by 5 and minus half. So that is y. Now using this y, you have to solve subsystem 2. So from 2 you are getting, from 2 what you are getting? Ux equals to y. You will get, what is u? What is u? U is 1, 1 by 4, 1 by 4, 0, 1 minus 3 by 5. So 1, 1 by 4, 1 by 4, 0, 1 minus 3 by 5, 0, 0, 1 into x. X is x1, x2, x3. And what is y? Capital Y is 1, 4 by 5 minus half. 1, 4 by 5 minus half. Okay. So from there, you will get upper triangular system. This is upper triangular system. Solve it by backward substitution. Solve it by backward substitution. So what will be x3? So let me write down the system what you are getting. So you are getting x1 plus x2 by 4 plus x3 by 4 equals to 1. x2 minus 3 by 5 x3 equals to 4 by 5 and x3 equals to minus half. So if you use backward substitution, what you are getting? That will be giving you x3 equals to minus half. What will be x2? x2 will be 4 by 5 plus 3 by 5 into x3. x3 is minus half. So if you simplify, you will be getting what? What will be x3? 4 by 5 minus 3 by 10. Four by 5 minus 3 by 10. How much?
1/2.
1 by tell me.
1/2, sir.
1 by 2. 8 by 10 minus 3 by 10. So 5 by 10. So that is half. And what is x1? x1 will be 1 minus x2 by 4 minus x3 by 4. So you have to simplify. Remember, we are just learning the technique. You will not be solving it by hand if you want to solve a system. You have to write a code. So that will be something like, let me simplify. It will be half na there. So it is 1 minus plus 1 by 8 minus 1 by 8. So that is 1. So what is the solution of the given system? x1 equals to 1, x2 equals to half, x3 equals to minus half. So this is the solution of the given system of equation, and we have obtained it by LU decomposition method. Next is LL star decomposition method. This is very similar to LU, only certain more condition has to satisfy the given system. So next is L transpose or Cholesky method. Cholesky method. What we are going to do in this method? So if you want to apply this technique, we want to make the calculation even less. Number of calculations should be smaller. So in a certain type of system, you can apply this technique, LL transpose or Cholesky method. So what is the sufficient condition for such decomposition L into L transpose? Sufficient condition for such decomposition is, you know, first criteria. What is that? Sufficient condition for such decomposition is what? Matrix has to be, what is the sufficient condition for LU decomposition?
Positive definite.
Definite. And for LL transpose, one more condition is required, that the matrix has to be symmetric. So positive definite, and second one is symmetric. Now, even though the matrix is not positive definite, it may have LL transpose, but symmetric it must satisfy. If the matrix is not symmetric, you cannot apply LL transpose. Otherwise, you will get inconsistent system. If the matrix is not symmetric, and if you try to find out LL transpose, it is not possible. If the matrix is not positive definite, it's okay, but it always has to be symmetric. So remember, this is sufficient condition, not necessary. So accordingly, you analyze it. So let us consider one example. How can we solve, and what will be the idea behind this? Now, before I tell you LL transpose, this LU decomposition can be used to find inverse of a matrix. In graph theory, the inverse of a matrix is required. I am not talking about solving system of linear equation. Inverse is used in other calculation also. So sometime if inverse is important and system is large, you can apply this technique. Once you know A equals to L into U, what will be A inverse? A inverse will be U inverse into L inverse. Now finding inverse of lower triangular or upper triangular matrix is relatively easy, because in that case the minors will be very easily calculated. So that technique you may use, finding inverse of a matrix. So here in LL transpose, so let us consider one system and try to understand it. So let us first explore the method for 3 cross 3 matrix. Example part you can do it yourself. Why the matrix size to be positive infinite? Why the matrix size to be symmetric? Huh? So suppose let us understand the method for 3 cross 3 matrix. So let us take an arbitrary 3 cross 3 matrix A11, A12, A13, A21, A22, A23, A31, A32, A33. That is the arbitrary matrix 3 cross 3. Okay. Remember, we just only have to know how to decompose. The other technique, how to solve a system of linear equation, that is same. From the given system, you will have to obtain two subsystem. One will be upper triangular, another will be lower triangular. Solve them using forward and backward substitution. Okay. So just we only have to know how to decompose the matrix, coefficient matrix as L into L transpose. So if the matrix is symmetric, what will be A21? What will be A21? And or what will be A12? Can you tell me what will be A12? This highlighted term. It will be A21. A12 equals to A21 for symmetric matrix. So I'll be writing this A21. 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 This element will be A31. And this element will be A32. A32. So take arbitrary symmetric matrix. Take arbitrary symmetric matrix. मैंने arbitrary symmetric matrix लिए 3 cross 3 order के. Okay, so now what we want to do, we want to decompose it in the form of L into L transpose. So L is L11, 0, 0, L21, L22, 0, L31, L32, L33 into L transpose. So L transpose will be L11, L21, L31, 0, so L22, L32, 0, 0, L33. So this is L, this is L transpose. So you complete the multiplication. So that will be L11 square. Next will be L. Let us keep some gap. L11, L21. Then it will be L11, L31, L11, L31. Next element will be second row into first column, second row into second column, second row into third column. So that will be L21 into L11. Then what you are getting? L21 square plus L22 square, and third element will be L21 L31 plus L22 Now the third row, so it will be L31 L31 L22 L32 L22 plus L31 L21. And here the last element will be L31 square, L32 square, L33 square, L31 square plus L32 square plus L33 square. So this is the, now if you see, if you consider L into L transpose, what is the multiplication matrix? Is that symmetric? Is that symmetric? Yes, these elements are same. These elements are same. So product is also symmetric. Okay, these elements are same. Yes or no? So how many distinct elements are there in the product matrix? How many distinct elements are there? Only 6. Okay, only 6. So if you compare the given coefficient matrix with the right hand side multiplied matrix, how many equations you are getting with how many unknowns? Here the right hand side number of unknowns are 6, because you see in L matrix number of unknowns are 6, and how many number of distinct elements are there in the right hand side matrix? 6. So you are getting 6 equation with 6 unknowns. That can be solved easily. Now if the matrix is not symmetric, left hand side initial matrix, if this is not symmetric, then you will get two equations whose values are different. If matrix is not symmetric, then what will happen? Then you may compare these elements and see what will be happening. If the matrix is given matrix is not symmetric, then you compare these elements and you see what will be happening. What will be happening? You will be getting two same equation on the left hand side, but their right hand side values will be different if the matrix is not symmetric. So it is not possible for a consistent system. That is why for having LL transpose decomposition, the coefficient matrix has to be symmetric. So now you solve. Now you solve for L1, L2, L3. So how to get L1? So compare the elements on the right side matrix to the left hand side matrix and see what is happening. So let me write down. So L11 will be, L11 is what? Under root A11. What will be L21 then? L21 will be, you do some calculation and find out the value. L21 will be A12 by L11. L31 will be A13 by L11. You see? So first column of L is obtained. Next will be second column of L. So you have to find out L22. So how to find out L22? So you have to compare accordingly and tell me what is L22. So L22 will be under root, after simplification, A11 into A12 minus A11 into A22 minus A12 square by A11, and L32 will be equals to 1 by L22 A23 minus L31 L21, and last element L33 will be under root A33 minus L31 square minus L32 square. So you see, if Aij, the left hand side matrix is known to you, if the left hand side matrix is known to you, then right hand side matrices L and L transpose can be obtained easily using this formula. So remember, this is formula. If left hand side is known to you, you can easily calculate what will be right hand side matrix. This will be same. Whatever matrix you consider on the left hand side, that has to be symmetric and positive definite. Why positive definite? Because see, when L11 will exist, L11 will exist if A11 is greater than 0. When L22 will exist, A22 will exist if this term is also greater than 0. A11 into A12 minus A12 square, if that is greater than 0. L33 will exist if this part is greater than 0. So what are they? They are nothing but the leading minors in the given coefficient matrix. Leading minor in given coefficient matrix is what? First leading minor is A11, then second leading minor will be determinant of A11, A21, A21, A22. So that will be giving you this value, the second highlighted part. And third leading minor is the determinant of the given matrix, that will be giving you the third highlighted part. So if they are all greater than 0, what does mean by that? It means that the given matrix is positive definite. So that is why the sufficient condition for existence of such decomposition is the given matrix is positive definite, and also it has to be symmetric. So if you get this kind of coefficient matrix, you can apply L transpose decomposition method, where L can be obtained very easily. Okay, so this was the idea. So once you get L matrix and L transpose, remaining part is same as LU decomposition method. You simply replace U by L transpose. So now what will be happening? Now the given system AX equals to B can be written as A is what? L into L transpose into X equals to B. You assume L transpose X equals to Y. Okay, so this is given system. Then it is equation number 2. Using equation number 2, you'll be getting Ly equals to B. So that will be equation number 3. So solve first equation number 3. Y will be known to you. Then using that known Y, solve equation number 2. Solve 2. Solve 3. Then solve 2 to get the unknowns. Now you see here the calculation is very less compared to LU decomposition method. But restriction is more. The matrix has to be symmetric. Huh? So this is the idea of LU decomposition method and LL transpose decomposition method. So I'll be ending the discussion. If you have any doubts, you can ask me. And if not, then you may leave the class. Let me stop the recording. Okay.